So I don't know. In principle, if I have done everything correctly, there should be a live video on YouTube, the same channel. So may you please go there and see if it's true. I can also might be check myself here on my phone. Okay. So I don't know if this is working or not. Are you already there? You can talk to me.
I can see the live stream.
You can see that. Okay, so now the problem is that, so let us see how it goes. Okay. And if you have whenever I ask you questions, I would appreciate say something so that I see that there is a delay, because I have adjusted this delay to very small, very few seconds. So let us see how it goes. Okay. And so if you remember, that was the problem that we were trying to solve. Yes. Consider an arbitrary point interior to a triangle ABC. So if I want to solve this problem, I have a triangle. So let me just draw one triangle here. Any triangle should work. Okay. Yeah, that's also a scale in triangle, so that's good. But then, what is the content of the problem? If LA, LB, and LC denote the measures of the perpendicular segments drawn from that point to the sides A, B, and C, respectively, and HA, HB, and HC denote the corresponding altitudes or heights of the triangle, prove that LA over HA plus LB over HB plus LC over HC is actually equal to 1. Okay, so how should we solve this problem? I have a point inside my triangle. Wherever it is, it doesn't matter. It should be interior to my triangle, yes? So here, for example, I will take this point, and then from this point, I draw a perpendicular line to the side. Let me give names to these vertices. So the triangle is mentioned to be ABC in the problem itself. Okay? And then I take a point inside this triangle and draw a perpendicular line from this point to all the sides of the triangle. So for example, I will draw this perpendicular line here. Okay? And I will call it L sub A. Why sub A? Because you know this convention that if this vertex is denoted by capital A, the side opposite to it will be denoted by little a. And I am saying, so this is why I put this index showing that this perpendicular line is drawn to this side A. So this is perpendicular. So this is 90 degrees. And I do the same thing with other sides. So okay, I will take this one and I will draw a perpendicular line to this as well. Okay, this is also a perpendicular line, but this is B, so this side by convention is B, so then I will call this one L sub B. Yes? And then the next one, similarly, I will draw a perpendicular line to this one, and that is equal to LC. Okay, so this I will call it LC. Okay, so here, and then you know that I have three heights or altitudes of my triangle. For example, let me just draw one of them. I don't want to make the picture very complicated. So for example, consider this height. Yes, this is one of the heights of this triangle. And then because this is actually coming onto BC, it is also this side is equal to A. So let me call this one H sub A. Okay, and then I will have two more, so let me not add them to this picture because the picture becomes a little bit more complicated. But what I am going to show is that if I measure the length of this one and divide it by the length of this one to construct this fraction, and I do the same thing for this one and the other HB, so assume that this is LB and this is HB. If I measure this size and measure this size and then divide them together to make this second fraction, and if I do the same thing for the third one here, for example, then I'm claiming that the sum of these fractions is exactly equal to 1, and it does not matter at all where you choose this point. If I have chosen the point somewhere here, of course LA would be longer this time, LB would be a little bit smaller this time, I don't know, LC is also a little bit smaller this time. But it doesn't matter. If I repeat the process for these lengths, then the sum of these fractions would be again equal to 1. Doesn't matter where I choose this point. So that's a very nice problem, I think, and we want to solve this problem. We want to prove it in a mathematical rigorous way that this is always the case. Okay, so now I want to ask you, I think there is a delay because I can see myself with a delay in my iPhone, okay? But, okay, can you tell me what should I do? Do you have any idea?
Could you try moving terms to the other side and then rewriting one as
May you please repeat?
move one of the terms to the other side from the left hand side to the right hand side, and then change one so that it's
Uh,
I don't know.
So this way of thinking is not wrong, but this is a scratch paper thinking, you know. So you manipulate, because you know that in principle we don't know this is true or false. Yes. So we actually, if you, this way that you are thinking means that, okay, let me manipulate this a little bit so that it gives rise to a simpler equality, so that in principle I should be able to solve that. Okay. But what I'm trying to say is that this is a question mark. So even if you do this, it means that you still know that this is a question mark. Might be your goal is to say that, okay, I will continue uh, with these double-sided arrows until I reach to something that is completely trivial for me. If that is your purpose, actually it is correct. But I don't see any way for doing that unless you yourself illuminate how. Any other opinions?
Mr. Babak,
Yes?
I think it would be better if you, because right now I have to mute the stream because you're not muted on Zoom, otherwise I get two voices.
Okay, thank you very much for informing me. Yes.
But that means that everyone else has to crank up the volume on your stream now. So
Okay.
is this?
Okay. So let us see how it works. Now, can you still hear me? Yes?
Yeah, I can hear you.
Okay. Okay. So, but there is a delay, so might be this is not a very good idea if you want to have questions and answers whenever you want to interrupt. So because when I can see that there is a 2 seconds delay when I ask something, I have to wait a little bit, 2 or 3 seconds, so that I can hear your answer. Okay. Either I have to get used to this way of teaching or I should give it up.
Maybe then it's better to mute the stream
Mute the stream.
and not mute on Zoom.
Okay, so let me see if I can do that.
Because then there won't be delay. But if
Audio input.
then I mean like everyone else can do it. I mean like we just do it like it was before. Then there won't be delay. But it will look a bit strange because you'll say something and then the
Yeah, so that's not a good idea. I would say that this is not a good idea if I want to communicate with you directly. So this is good for if I want to just teach, and then after that wait for your questions. So yeah, at least for Mat 5 that I want to start today, I will not try to do this even though I have already scheduled everything. So but my channel is not that crowded. Hopefully there are no other people from other places to join the live stream. Okay, but if you don't mind, let me just solve this problem in this way, and then we finalize, we go back to Zoom, and then if you have any questions, we can talk there, okay? But just this is one problem, so you can just see how I solve the problem, okay? Uh, okay. Okay, so now what I want to solve here would be using the idea of the area, okay? If I can do this, if I want to use the idea of the area, and I think it is not that hard to understand how I want to do that. So for example, let me change my color here now to, for example, this one, and then I say that, okay, let me connect these vertices to this point that I have already chosen, okay? So this, I will connect this to this and that, and there is also one more thing here. And then something clear is something becomes clear if you concentrate here on this triangle and then this triangle, yes, and then this triangle, it is completely clear if I add the areas of these three triangles, it becomes the area of the whole triangle. Yes, so what I can write, let me give this a name. So I will call this point O. It becomes clear that the area of triangle ABC is equal. Area in geometry is denoted by S. So when you say area, that is denoted by S, or something like a surface. Okay, so the area of the triangle ABC is equal to the area of triangle OAC plus the area of the triangle OAB plus the area of the triangle OBC. Okay, this is clear. But if I ask you, let me simply write this as just simply S. Okay, so let me write this one. On the left hand side, I would write S. What I mean by S, I mean the area of the triangle ABC. But if I ask you what you can write for the area of this triangle, let us see which triangle it is. This triangle, we have this triangle, and I want to find the area of this triangle. What I need to do, I need to write 1 over 2, yes, of the base, but here this will play the role of my base. It doesn't matter which side you choose. As far as you choose the corresponding height, you can multiply that side by that height and then divide it by 2. So if I write B times LB, I think it would become clear that this is the correct area for this triangle, yes? Because let me repeat it once more. So I have a triangle here. I want to find the area of this triangle. I will consider this the height. Why this can be the height? Because it is perpendicular by the assumption of the problem to side AC. So this can play the role of the height of my triangle. If I take this as the height, I have to take this one as the base. But this one has the name B. So when I write 1 over 2 B times LB, I am actually calculating the area of this triangle. And I think the idea is now very clear. The next one, I can write something similar for that. So which triangle is that? Triangle OAB. So this is my triangle OAB, yes? Now I will take this one to be my height and then this one to be my base. So I can write 1 over 2 CLC. And finally, the last one. This is the triangle that I am concentrating on now. This can play the role of the height of my triangle. This can play the role of the base. So this becomes 1 over 2, yes, ALA. Okay? Now what can I do? At least this is a nice relation, because if you see, I have two sums here. Here I also have two sums. And I have LA, LB, LC here. Here I also have LA, LB, LC. But of course this is not still 100% right. I need to make it right. Another guiding point is that you see I have 1 on the one side of this relation, but here I don't have this equal to 1. So there is a very simple idea how I want to make this one equal to 1. So I have to divide by S. Yes? So I divide both sides by S. The left hand side becomes 1. The right hand side becomes 1 over, let me write it in order. It becomes 1 over 2a times LA over S. But remember, what was S? S was the, you see, S was the area of the big triangle, yes, this bigger triangle. Okay, so then this plus 1 over 2b times LB divided again by S plus 1 over 2 CLC divided by S. Okay, but you know that for any triangle, I can write the area in 3 different ways depending on which side I am choosing for the base and which height I am choosing as the height. Yes, so I have 3 formulas for S. Yes, so S can be written as 1 over 2 AHA. Yes, is that understandable? So this is A, this is HA. So if I want to calculate the area of the big triangle, one way of doing this is this. But you don't need to stick to this as the base and this as the height. You can choose this as your base and this one as your height. This one is called H sub B this time. So this is also equal to 1 over 2 B times HB. And similarly, you can write it as 1 over 2 C times HC. So all of them are the formula for the same quantity S. But then the idea hopefully becomes very clear. For this S, I choose this for relation, this formula. For this S, I choose this one. For this S, I choose this one. Because all of them are actually S's, so that is up to me which one I want to use. And then I think it's clear that what will happen. So here, instead of, so I will repeat this one here, it becomes 1. On the right hand side, I will have 1 over 2a LA. Instead of this S in the denominator of this fraction, I choose the first formula for S, plus, for the next one, I write the numerator as it is, and I divide it by S, but this time I choose the second formula for S. That's up to me which one I want to use, yes? And for this third one, I copy and paste the numerator as it is. And then for the third S, I choose the third formula for S. And then hopefully everything suddenly becomes clear, because this 1 over 2 and this 1 over 2 are gone, this h and that h are gone, so what is left from the first fraction is just simply LA over HA, yes? And then the next one, for the same reason, 1/2s are cancelled, b's are cancelled, what is left is LB over HB, and then the next one I will have LC over HC. And that is exactly the relation that we want to actually prove. Okay? So, I mean, that is a simple problem, but you need to be a little bit more experienced and creative to be able to solve this problem. Okay? So I think it would be better to end this live stream here and go back to Zoom. So if you have any questions, I can answer your questions there. Okay? Okay, bye bye here. I will be in Zoom.